This is Calculus with Mr. Allenson, and we're doing problem number 5 from the Form B 2005 BC test. It's problem 5, so it's a non-calculator problem. And what it asks you to do is to consider this graph of this curve f of x here, which is equal to 1 over x plus 2 from 0 to infinity. They separate it up into two regions, regions R and regions S, which is broken up by this line x equals k, as long as k is anywhere from 0 to infinity. They don't really tell you where k is. It's kind of a variable essentially. So first they say for A, find the area of R in terms of k. So I'm going to take the integral from 0 to k, wherever that is, of 1 over x plus 2 dx. Take the antiderivative and get ln of x plus 2, plug in k and 0, and I get ln of k plus 2 minus ln of 2. For B, they asked you to find the volume of the solid generated when R is revolved around the x-axis. So when R is revolved around the x-axis, you notice that it's disks, and the radius is from 0 to this function 1 over x plus 2. So the volume of R, volume of the R, is equal to pi times the integral from 0 to k of the radius squared, so we get 1 over x plus 2 squared dx. Working this out, taking the antiderivative, I should get negative pi over x plus 2 from 0 to k. Plugging those in, I get negative, actually negative, so I get negative pi over k plus 2 plus pi over 2. For C, it asks you to find the value of k that will make this region R, this volume of R, equal to the volume of S if I were to rotate S. And the tricky thing about S is S goes on forever to infinity. So what I want to do is try to make an expression for the volume of S and set it equal to the volume of R and kind of see where that happens. So the volume of S is going to be equal to pi times the integral from k to infinity of 1 over x plus 2 squared dx, which is equal to the limit as b goes to infinity of negative pi over x plus 2 from k to b, and that's going to be equal to pi over k plus 2. Now you want to see when that volume is equal to this volume. The volume of R is equal to the volume of S. So we're setting these equal. Negative pi over k plus 2 plus pi over 2. When is it equal to pi over k plus 2? And so solving that, you should get 2 over k plus 2 equals 1/2. And that happens when k is equal to 2. So the points in this one, 2 points for A, 1 for the integral, and 1 for the anti-differentiation and evaluation. B, 3 points, 1 for the limit, 0 to k, 1 for the integrand, and 1 point for the anti-differentiation and evaluation. For C, 4 points, 1 point for the improper integral, 1 point for the antidifferentiation and evaluation, 1 point for the equation, and 1 point for the answer.